Sorry, I gotta switch my. There you go. Now you can see the right thing. Okay, so today we're talking about section 1.3. This is an entire section where the main focus is actually going to be on what makes a good definition. And this is going to be pretty different than if we were in class. Normally, I'd put you in groups and we'd be doing a lot of kind of discussion with our groups and with the whole class. But hopefully we can do a little bit of kind of get that feel, even though you're not actually here. So our objectives today are going to be to practice writing definitions and then using what are called counterexamples to help us make those definitions even better. And today we're going to happen to focus on angles as some of our definitions. We talked about angles in section 1.3, which you watched those videos on Monday. And so we're going to talk about some special types of angles. So there you've got some of your vocabulary words. If you want to pause the video right now and kind of get your glossary set up, for sure you're going to want to write in the words right angle, acute angle, obtuse angle, vertical, complementary, supplementary, and linear pair. I wouldn't put those first four in your glossary. Those aren't going to be as important. We definitely need to talk about those, but don't put those in your glossary. So the first thing here, I'm not sure if you can see my screen. I'll drag that out of the way. I want you to take a second here and think about this question. You've got a group of four little things there that your book is going to say are widgets. You got the next four things that are not widgets. And then you've got A, B, C, and D. Which of those are widgets and which ones do you think are not widgets and why? So I'll pause the video and there'll be a spot for you to type those in. Okay, so your answers to this one are going to be a little tricky. So the big question here is going to be, what makes a widget a widget? And one of the things you might want to ask yourself is, what do all the widgets have in common? And what things do widgets have that others don't? And so I'm actually going to roll back here, I think. And if we look at the widgets, you're going to see they have some defining features here. They all happen to have one of these little eye things on them. They all happen to have one of these little claw things on them. And they all happen to be filled in with a various different color. Now, that in and of itself, if we just stuck with that, is going to tell us that A looks like a widget. B does not. It does not have an eye thing. C looks like a widget. And D does not. B and D don't have those eyes. Eyes, creepy. Now, it's also important that we look at this not a widgets thing. This one here, pretty clearly not a widget, doesn't have the eyes. This one has an eye and a tail, but what makes it not a widget? Probably that it's not filled in with some sort of a color. This one here has an eye and a tail. It's filled in. What makes that one not a widget? Probably that it has two tails. So maybe we can say, well, two tails is not good. We need to just have one. And then this last one's going to be pretty important here. It has an eye. It has a tail. It's filled in, but it's got these things inside of it. So does that mean C is a widget? Probably not. It's got something inside of it. Things inside of it appear to not be widgets. So if that's the case, if we define a widget as has an eye, has a tail, is filled in with a color and has nothing else in it, then our only widget would be A. And that's usually what most people agree with, that A is the only widget in the group. So if we look at a definition, we talked about, I think at one point, that a definition just explains what a word is. But in math, a good definition has a couple of different characteristics. It is going to classify the thing you're defining and is going to differentiate the thing that you're defining. Classify, differentiate. Those are your two really, really big things. And so they give you an example. A protractor is a geometry tool that is used to measure angles. What is it? A geometry tool. What does it do? Measure angles. And so I want you to give this one a shot too. Try to write a definition for a square. Pause. I want you to type that in and fill it out in this form. A square is a what, that, how is it different from other things? Okay, now I want you to take a look at these examples here. Chances are you wrote a definition something along the lines of a square is a shape with 4 equal sides. All of these, according to that definition, are squares. This one right here has 4 equal sides. This one's got 5 equal sides, but 4 of them are equal too. This one here has 4 equal sides too. Why aren't these squares? We've got to be a little bit more specific. So maybe a better definition here would be a square is a 4-sided figure that has all sides congruent and all angles measuring 90 degrees. So we need to make sure that we're being as specific as possible with these things. We don't want to end up in a situation where, according to our definition, something that isn't really a square can count as a square. Okay, so we're going to do a little activity here, and I'm going to kind of work through this like you're going to do it on your own. I'll let the video pause so you can type something in, and then we'll talk about it after that. Before we start here, a couple of really important things. You've got 2 symbols here and 2 little marks in the pictures. The first one here we've got are these little arrow marks on these lines. And what that means is that those 2 lines are parallel to each other. The same symbol written down on paper is going to look like this. So here you've got line I and line J, and this is the symbolism for line I is parallel to line J. Then you go over here, these little squares in the corners, they mean 90 degrees or perpendicular. And this symbol here that looks like an upside down T is the perpendicular symbol. So here you've got lines K and L, they've got the perpendicular symbols, and this is just saying line K is perpendicular to line L. We definitely need to be using these symbols a lot. You're going to be writing those down in your homework. You're going to be reading those. You need to know what those mean. Same thing with these symbols that are in the pictures. You're going to be doing that a lot. So keep in mind when we write these definitions for the next couple of slides, you need to classify your thing and you need to differentiate it. How is it different from other things? And then look at the counterexamples. Do any of them match up? So I think we should do this first one together. Actually, definitely we need to do these first ones together because there's not a counterexample here. Parallel lines. If you look at these parallel lines here, we talked about how those are the arrows and then this parallel symbol. Parallel lines are lines that never cross, right? Technically speaking, they have to be in the same plane. So you can think of a plane like a piece of paper. So 2 lines that are drawn on the same plane, on the same piece of paper, but never cross. Even though they go forever in both directions, they never cross. And then perpendicular lines are lines that cross at right angles or 90-degree angles. And so there you go. There's the example of those 2. And you'll notice that those definitions do both things. They classify and they differentiate. Parallel lines are lines in the same plane. And what makes them different from other lines in a plane? They never meet. Perpendicular lines are lines. And what makes them different? They meet at 90-degree angles. Okay, let's let you try one of these. I'm going to give you a little sentence starter before I pause the video. So the first example is right angles. And I'm going to have you fill out this kind of thing, and I want you to say a right angle is a blank, fill in that blank. Remember, what is it? Classify it. How is it different from all the other things like it? Go ahead and type that in, and then we'll be right back. So chances are you hopefully came up with something like a right angle is it's an angle. And then how is it different from every other angle? That and a right angle is 90 degrees. So I'm going to use measures 90 degrees. That would be an excellent definition for a right angle. And if you look back at the counter examples, the 2 examples that were not right angles were 46 degrees and 105 degrees. Definitely not 90 degrees. So that's our definition for a right angle. Okay, back to the PowerPoint. Okay, next definition is an acute angle. Now remember, we're going to write a definition like an acute angle is a blank that blank. How is it? What is it? How is it different from all the other ones? Go ahead and write that in. Okay, so again, kind of filling in our definition spot, an acute angle is a, well, what is it? It's an angle. And how is it different from all the other angles? You notice you got 33, 56, 89, and then not acute angles were 100, 91, and a right angle, 90. So it's got to measure less than 90 degrees. 90 degrees is a right angle, less than is an acute angle. Now, if you're adding these to your glossary, these would be really, really good definitions to add to your glossary. If yours didn't quite include all of that information, make sure you're adding that so you have that. Okay, next one up is an obtuse angle. Go ahead and give that a shot. Okay, so hopefully you've got something that kind of fills the same pattern. An obtuse angle is, you guessed it, I forgot the N. Your English teachers are going to murder me. An angle that measures more than 180. Or more than 90. Now, some of you might have put it has to be less than 180 degrees. We don't technically need that part because when we talk about the measure of an angle, we're always talking about something that's less than 180 degrees. If you put that in, perfectly fine. Next, complementary angles. This one's going to take a little while. Hint here, you're talking about two angles. So you might have something like complementary angles are two angles that what? Okay, welcome back. Let's take a look at what we might have for a definition there. Complementary angles are, this time it's got to be two angles, can't be three. If you looked at yeah, they didn't even have any examples that were more than two. So it's got to be two angles that, how do we want to word that? Add up to 90 degrees. We could even say whose measure add up to 90 degrees. Oh man, someone's calling me. Okay, put that away. So complementary angles, two angles that add up to 90 degrees. Next up, we've got supplementary angles. Go ahead and type in a definition. Okay, so this one's going to be seemingly pretty close to complementary. Supplementary, make sure I spell supplementary right. Supplementary angles are, again, it's got to be two angles. They give you an example in there where there's three angles that add up to 180, but it's got to be two angles to be supplementary that add up to, in this case, it's 180 degrees. Okay, now the next couple here are going to be a little trickier for most people. In class, this one's always the one that gets people. So let's take a look. We've got vertical angles. Pause the video, see what you think. Okay, so usually in class, I'll get a couple of different answers here. I sometimes get something that says vertical angles are angles that are equal. Maybe. If you look at 1 and 2 here, they certainly do look equal. Same thing for something like, over here, 5 and 6, they look pretty equal as well. But the main thing is we actually have no idea if those are equal or not. So we can't really use that one. One thing we know for sure, it's a pair. It's got to be two angles. So we might say something like, let me switch over here. Vertical angles are, again, two angles And one word that a lot of people will like to add in here, which I think is good, is opposite. And what that means is if you look back at our picture here, they're always across from each other. 1 and 2 across from each other, 3 and 4 across from each other, AED and BEC across from each other. They're opposite from each other. So opposite angles formed by two intersecting lines. You could also have something like that are, if you like that kind of format. Angles are that blank. Something like that's usually what we go with. Next up, we've got a linear pair of angles, and this one is definitely a tricky one. And this is the last one, thankfully. Okay, so this one's a kind of tricky one. The definition your book gives, I personally don't like that very much. I usually go with a linear pair are two angles that form a straight line. Now, I will show you the book's definition on this next one, and it might be a little better than mine, but it's also a little kind of confusing in the way they word that. So I'm going to show you the book's definitions. They're mostly the same as what we have written down here. I would say make sure you've paused the video and add in all of those definitions to your glossary if you haven't already. And there we go. So make sure those definitions are in your glossary. Pause the video if you need to, and we'll move on. Here we go. Okay, so we're into the summary part here. A couple of questions. I want you just to pause the video and think about those. I'm not going to have you type anything in. What makes a good definition? Why did we need to say the words in the same plane for parallel lines? And what is the difference between supplementary and a linear pair? That last question is pretty important. So let's talk about these. I'm not going to put the answers up on the board. What makes a good definition? The two things we talked about, it has to classify the thing and it has to differentiate it from everything like it. General format there of a definition that we're going to have, a whatever is a blank, that blank. All right, that's kind of the idea. Why do you need to say in the same plane for parallel lines? So here's something I want you to envision here. Take a look at this line. We'll call it line L. And imagine that my pen was another line coming right out of the page at your face. Do those two lines ever cross? No, but they're not parallel to each other, right? So we have to say in the same plane. L and K, those could be parallel because they're in the same plane. A line going like this doesn't cross, but not parallel. Okay, and then the last one was the difference between supplementary and complementary, or sorry, supplementary and a linear pair. They kind of look the same, and if you actually look back at the picture of like the linear pairs, would you agree that 1 and 2 add up to 180 degrees? Sure. The difference there is a linear pair actually has to be next to each other. They have to be touching so that they make that straight line. Supplementary angles, I could have one here and I could have one across the world and they'd still be supplementary. Linear pairs literally have to be together. And so it would look like this. Those could be a linear pair of angles, where supplementary might look more like this. Those are supplementary, but not a linear pair. They have to be together. Okay. I do want to take a look at one of these questions as just an example before you start the practice about how specific I need you to be. So let's take a look at something like this, number 4. I'm going to go ahead and make that one of your homework questions so that you've got one of them done, basically. So we've got, if we read this, line segment DG is parallel to line MS. That's what that thing says in normal English. So if I were to take that and try to draw it, I need to make sure that what I draw is a line segment and a line, that it's labeled with the correct letters, and that they are parallel, and that those parallels are marked. Lots going on there. So if I'm going to look at that, I'm going to see something like this. I need a line segment, and I need a line that are parallel to each other. So they should look pretty parallel. The line segment should be labeled DG. The line should be labeled MS. The line should have arrows on the end because it is a line. And in order to show that they are parallel, I'm going to use the parallel symbols. I don't think I mentioned this already, but the example in your book gave the two, like a double arrow. You don't need the doubles. If there's one set of lines that are parallel, you can use a single arrow. If there's another set somewhere else, then you can use the double arrow or triple arrow, whatever you need. So be on lookout for that in your homework. Make sure you're being very, very specific. There's not a wasted symbol or word in these. If it, everything is important that gets marked down. That's kind of what we're practicing right now. Okay, so what you're going to have for homework is going to be a few of these questions, quite a bit of these first ones, and then a few from later on. We might do one here. These are Zoids. We had widgets, now we've got Zoids. So see you all hopefully tomorrow, and I think there'll be one more video that you've got to watch today.